So modelling, we use the same processes all the time. We've got to think about where our domain has to exist over, because typically if we're modelling, we're recording something, we're measuring, we're counting. So negative X values typically aren't appropriate. To model real situations for our expos and logs, typically it's about the growth of populations, or it might be the decaying of elements, things like that. That's the key one there. Typically we're going to start at t equal to 0. All right. So let's have a look at this one. A population of wombats in a gully is given by the rule W equals E to the 0.03 t. Number of wombats t years after the 1st of January 1998. Initial size of the population. So initial anything means t is equal to 0. So W is equal to 100 E to the 0. E to the 0 is 1. So my population starts off with 100 wombats. Find the population 2 years and 10 years after the wombat population is first recorded. So that's, as it suggests, t equal to 2. W is equal to 100 e to the 0.03 times 2, which will give me 106.1. So we'll call it 106 wombats. And then at t equal to 10, we get W equals 100 e to the 0.03 by 10, which will give me 134.9, which is 135 wombats. So just substituting into our equations on our CAS, sketch the graph. So again, it's just a positive exponential. At t equal to 0, W is 100, which is there. Now, normally my graph would increase like this, but obviously since we're sketching over a real population, let's get rid of that stuff there. So let's put in 100 there, and that's the rate at which my population increases at. We're also stopping at 30. So let's stop there. So t, there's my t axis, there's my w axis, and that's t equal to 30. So if I check t equal to 30, w will equal 100 times all of that. So just on my calculator, I get 245, which is say 246. So I get the point 30 to 46. So less than equal to, less than equal to. So let's use solid dots. Put our coordinates in. So we've got everything labelled as we should. Okay, find the expected size of the population in the year 2020. So the year 2020, so let's have a think about that. So if t equal to 1, that's 99. T equal to 2, that's 2000. So even if we have to use our fingers, which is what I'm going to do, so 2000 is 2. So then we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 22 years, I hope you counted up. So t equal to 22 is the year 2020. So we're just going to put W is equal to, what is W equal to? 100 e to the 0.03 times 22. If I go to my calculator and type that in, I'll get 193.47, which is 193.47. So we'll round that to 193 wombats, to the nearest wombat. Find the area in which the population reaches 250. So that means I need 250 of the population size, W, to be equal to 100 e to the 0.03t. So 250 on 100 equals e to the 0.03t. So that's 2.5. So log base e of 2.5 equals 0.03t. So t will equal natural log of 2.5 over 0.03. Now, we could have quite easily just gone straight for the solve button. 2.5, and that would have been fine, but I just thought it's worth showing you how you might need to solve it in a tech-free environment, and that's 30.54 years. Find the year in which, so when is 30 years later? So 30 years later, so if we start in 1998, 30 years later will be the year 2028. So it'll be during 2028. Okay, so there you go.